Imagine paying $100,000 for an airplane and outrunning a $500,000 Cirrus. That's not a marketing claim. That's the TL-2000 Sting S4, a carbon fiber predator built in the Czech Republic that the American aviation industry quietly pretends doesn't exist. 135 miles per hour, 850-mile range, a glass cockpit, heated leather seats, and a whole aircraft parachute standard. Not optional, standard. This machine weighs less than 800 pounds empty, and it will humble aircraft that cost 5 times more. Welcome back. Today we go deep on the aircraft that changed what ultralight means forever. Where it came from. Most people, when they think of cutting-edge aircraft manufacturing, think of the United States, maybe France, maybe Germany. Nobody thinks of the Czech Republic. And that's a mistake, because somewhere in the city of Hradec Králové, a quiet city in the northeastern part of the Czech Republic, a company called TL Ultralight has been quietly building some of the most advanced composite aircraft in the world since 1990. They didn't start with exotic jets or military contracts. They started with gliders, simple, elegant, efficient gliders. And from that foundation, a deep understanding of aerodynamics, lightweight structures, and precision engineering, they built something extraordinary. Their early aircraft, the TL-32 Typhoon, the TL-132 Condor, the TL-96 Star, these were stepping stones, each one teaching the engineers something new, each one pushing the envelope a little further. By the late 1990s, TL Ultralight had a vision. They wanted to build an ultralight aircraft that didn't feel like an ultralight. They wanted something with the performance of a certified single-engine aircraft, the safety features of a much more expensive machine, and the efficiency that only comes from obsessive weight reduction and aerodynamic refinement. The result was the original TL-2000 Sting, and when it debuted, the aviation world took notice. Nearly 400 units of that original Sting carbon were built and sold worldwide. That's not a small number for an aircraft in this category. That's a phenomenon. Pilots from the United States to Europe to Australia were buying these Czech ultralight machines and discovering something that the spec sheets couldn't fully capture. This airplane was alive. The evolution. How the S4 was born. But TL Ultralight didn't stop there. After a decade of flying the original Sting carbon in the real world, collecting data, talking to pilots, reading NTSB reports, listening to complaints and praise, the engineers in Hradec Králové went back to the drawing board. They didn't redesign the aircraft, they refined it. Every weak point was addressed, every complaint was cataloged. The cabin was widened, the avionics bay was redesigned for modern glass cockpit systems, the aerodynamics were fine-tuned with sophisticated computational fluid dynamics that simply didn't exist when the original Sting was designed. The result debuted at Aero Friedrichshafen, the world's largest general aviation trade show. The crowd's reaction told you everything you needed to know. This was the TL-2000 Sting S4, the fourth generation, and according to the engineers who built it, the perfected version of everything the original Sting promised.
The engineering. Let's talk about what's actually inside this machine, because the numbers are genuinely impressive. The primary structure of the Sting S4 is 85% carbon fiber, not fiberglass, not aluminum. Carbon fiber, the same material used in Formula One chassis and aerospace components. But it's not just the material that matters, it's the construction method. The wing skin and fuselage are built as a sandwich, layers of carbon fiber, foam core, more carbon fiber, all bonded together with epoxy and then cured under vacuum in an oven. The most highly stressed components go into an autoclave, a pressurized oven that essentially mimics the manufacturing environment used by major aerospace companies. What you get from that process is a structure that is simultaneously incredibly light and incredibly strong. The airframe is stressed to +6, -4 G. That means at maximum gross weight, this airplane can handle aerobatic maneuvers that would structurally destroy many certified aircraft. Empty weight sits around 780 pounds. Maximum takeoff weight is 1,320 pounds, the legal limit for a light sport aircraft in the United States. That gives you 540 pounds of useful load. Subtract your fuel, 32 gallons in the long-range configuration, and you still have room for 2 full-sized adults plus baggage. Now, the performance numbers. Cruise speed, 135 miles per hour. Top speed, approximately 137 miles per hour indicated. Never exceed speed, 178 miles per hour. Stall speed, 49 miles per hour. That is an enormous speed range. It means you can fly slow and smooth into a 2,000-foot grass strip, or you can open it up on a cross-country flight and cover 850 miles on a single tank. Climb rate, 1,000 to 1,200 feet per minute. For context, that's competitive with a Cessna 172 Skyhawk carrying a much more powerful engine. And then there's the glide ratio, 12 to 1. 12 feet of horizontal distance for every foot of altitude lost. That is the glide ratio of a well-designed light touring aircraft, not an ultralight. The power plant options are all from Rotax, the Austrian engine manufacturer that dominates the light sport aircraft market for good reason. You can specify the 80 horsepower 912, the 100 horsepower 912S, the 115 horsepower 914 Turbo, or the fuel-injected 912IS, which brings modern engine management technology to an aircraft that previously relied on carburetors. The propeller on most configurations is a 3-blade DUC swirl composite unit, ground adjustable, carefully matched to the Rotax power curve. The cabin. The cabin is 44 to 45 inches wide. For comparison, a Cessna 172, arguably the most successful general aviation aircraft ever built, has a cabin width of 40 inches. The Sting S4 is wider. 2 seats, side by side. Full-sized adults can sit next to each other without shoulder contact. There's legroom, there's headroom. The seats can be ordered in heated leather, the same type of option you'd find in a high-end sports car. The instrument panel has been redesigned in the S4 iteration, specifically to improve sight lines for the pilot. The passenger side dashboard is angled away, a small detail that makes a significant difference in cockpit situational awareness. Standard avionics on modern S4 configurations center on the Garmin G3X Touch, a glass cockpit system that displays attitude, airspeed, altitude, GPS navigation, engine parameters, and traffic information on a large touchscreen display. The same system used in aircraft costing 3 to 5 times as much. The canopy opens from the front, hinged at the leading edge, giving both occupants a wide, unobstructed entry. Once you're seated and locked in, the view out of the bubble canopy is panoramic. There's very little to obstruct your visibility in any direction. And the wings. This is a detail that doesn't get enough attention. They can be removed. In about 30 minutes with basic tools, you can fold the Sting S4's wings for ground transport or trailer storage. That means you don't need a hangar. A trailer in your driveway is a legitimate option.
Subscribe if you want more aircraft deep dives like this. Drop a comment below. Would you fly the Sting S4? See you in the next one.